Okay, so hello and thanks for coming. So today I'm going to talk about a strange little programming language called Clojure and why it's useful for doing creative stuff and creating various things. So before I begin, how many of you are programmers? Can you just raise your hands if you're programmers? Okay, so most of you. How many of you have used Java? Okay, most of those people who are programmers have used Java. How about Ruby, Python, Lisp? Okay, very few. And Clojure? Just, yeah, 1.5 people. Okay, cool. So hopefully most of this is new to you. People who have used Lisp before might recognize some of this. But if you have a laptop and you want to follow along with the slides, you can just follow this URL here. I don't see any laptops, so it's alright. But yeah, if you want to get the slides later, I'll show this again at the end, so you can write it down or whatever. Also, yeah, again, I'll post it onto the meetup group. So first about me, I'm just really an NGD student, which is like it's like a PhD in industry. So I do research at the University of Bath and for a small company in Bristol called Sysemia. And most of my research involves procedurally generating narratives and stories for games. And most of that's done in Java, to be honest, but I'm trying to use more and more Clojure in my research because it's a very useful language for that kind of stuff. And just in general, I love kind of tinkering with different languages. And like one day I discovered Clojure and thought, wow, it's a really interesting language. So I kind of just want to like talk to people about it and say, hey, there's all this really cool stuff going on in the Clojure world. I'm one of the organizers of the Bristol Clojure Dojo, which is a meetup we have once a month where people can just turn up and learn new things in Clojure or just learn how to use Clojure. And it's held at the Nokia offices on Wine Street in Bristol. Our next meetup is on May the 20th. And we're learning about how to make synthesizers and music in Clojure using a library called Overtone, which I'll demonstrate to you a bit later. Okay, first, what is Clojure and why should you care? It's a fair question. Clojure is a dialect of an old programming language called Lisp. And I'll explain what that is later. But it's similar to these old languages, but in a good way. It's kind of a modern, updated version of it. But importantly, it runs on the Java virtual machine. So those of you who know Java know that the JVM is this amazing ecosystem with loads of libraries that have been written and are really, really useful. And the great thing about using the JVM is that you don't have to rewrite everything from scratch. You can take advantage of all this work that's been done before. So you can use all the libraries from Java from Clojure, which is great. But part of the design and the reason you'd use Clojure over Java is that it's really good for concurrency and parallel programming. And the reason for this is because it encourages using immutable data structures all the time. And that's really good for concurrency because you can kind of know what state your program's in. Because, so if you don't do programming, I should explain what immutable means. It means that if you have some data, you can't change it once it's kind of defined. And that means that when you do concurrency, when you use something with, say, a CPU with multiple cores, you can kind of split things up, your program up, and process different parts of it at the same time. And Clojure and its immutability makes that a lot easier. And also, the last point is, I think that the syntax is really simple. Some people might debate this with me, but I think if you're totally new to programming, and you had a choice between Java and Clojure, you would find the syntax of Clojure more simple. But I think if you're used to programming, if you're a kind of seasoned programmer or developer, the syntax would be totally alien to you, so you might argue with me and say, actually, it's not that simple. But I think it is simpler than Java. So here's an example of the syntax. So this is a function called myFunction, and it takes two arguments, x and y. And at the beginning here, we're saying, okay, let xs equal x times x. And what's interesting about this is that the syntax is always uniform. You always have the name of the function at the start. So the name of the function is this asterisk that's multiplying. multiply, and then the two arguments, x and x, and then let y's equal y times y. And then, so it's saying let these two things, it's kind of like defining variables in other languages. And then you have at the start here, math square root. So that's calling a function from Java in the math library, square root. And then you're adding x's and y's. And in JavaScript, you'd write it like this. You'd say, well, my function equals function. I'm sorry, I'm assuming most of you know JavaScript. Hopefully, if you know Java, it's not the same at all, but you might understand this, probably. So you define a function, my function, function x, y. So yeah, you've taken the two arguments x, y. You're defining a variable xs, which is x times x, variable x, y, x times y. Y times y, sorry, returns square root xs plus ys. So, yeah, so those programs both do the same thing. But the thing with the Clojure syntax is that it's a lot more kind of regular in a way. Like you always have an enable function at the beginning, and this is important because it means that the structure of your code is a tree. So, if you go back to the code now. So the last thing, I should also add this, the last line is always returned in a Clojure function. So you don't have to type return like in other languages. So this is automatically returned. So if you look at the tree, you're calling math square root function. The top thing of the tree is always the name of the function. So math square root on the combination of xs and ys. And xs is x times x, ys is y times y. And the root node of a tree, is the name of the function. So the first thing in these brackets is always the root node of a tree. And the second thing is always kind of like the leaf, the branches, the leaves. And that's really important for a reason I'll explain later. But it means because you can reason about your programs in this way, it's a really powerful thing. Okay, so I mentioned before that Clojure is a dialect of this other language called Lisp. So I should probably explain what Lisp is. Now, Lisp is actually a really old programming language. It's like one of the oldest high-level programming languages that exist. It was actually designed in 1958 by an artificial intelligence researcher called John McCarthy. And it's actually a multi-paradigm programming language. So when I talk about paradigms, I mean like the most popular paradigm now is arguably object-oriented programming. So Java really kind of forces this paradigm on you. But with Lisp, you can choose your paradigm. You can do object orientation, or you can do functional programming. And people who use Lisp and Clojure tend to use functional programming instead, which is like programming in a way that's close to mathematics. You use functions and manipulate functions to functions. And I think that programming is kind of evolving in this direction, more towards functional programming. It encourages metaprogramming, which again I'll explain later. It means you can kind of rearrange your program as it's running, in a way, and define your own languages in the language. Historically, the most popular dialects of Lisp were Common Lisp and Scheme, but now Clojure is this new dialect which is becoming more and more popular. When I say dialect, I mean like the language is essentially the same, but there are little differences. So Lisp is kind of infamous for being really hard to read. Like some people say that Lisp actually should stand for lots of irritating, silly parentheses because you have all these brackets everywhere, and it's kind of confusing. Everything's nested. So if you look at some code like this, you'd say, you can't read that. How can you make sense of that? But if you have a modern IDE or a modern text editor, or even an old text editor like Emacs or Vim, you have indentation and you can read it pretty well. I mean, yeah, if you're not used to Lisp, maybe this is still hard to read, but once you get used to it, it's quite easy to read. Yeah, usually I think that cartoons or comics in a presentation are a really bad idea because normally people laugh out of just like blindness more than anything. You aren't even doing that, so thank you for humouring me. But you probably can't read this at the back, but there's this XKCD comic, which is great. It absolutely captures the essence of what Lisp is and why it continues to be popular. Like they're saying that it has this kind of timeless quality. It was created, half a century ago, but people still use it. And it's like people keep rediscovering why it was good. And yeah, that's absolutely right. The thing is though, with Lisp, like people, you have these advocates who love this language, and they say, okay, this year Lisp is going to be mainstream. Everyone will suddenly understand why it's so good. And it never really seems to happen for some reason. It's like Linux on the desktop, you know. Every year we think, oh, everyone's suddenly going to start using Ubuntu or, you know, some distro, but it never quite happens for whatever reason. Okay, so now I'll just talk about some syntax. Okay. Can everyone read that at the back? I can increase the font size. It's probably, you okay? Yeah? Oh, great, cool. Okay, so, I'm going to have to kind of crouch down here to use my laptop. Sorry about that. So, in Clojure, you have namespaces, which is how you define modules. Kind of like in, I think Java has this and C# too. So, I'm doing all this in a namespace called CLJ demo. So, as I mentioned before, you have this prefix notation. So, the function name is always at the beginning. So, we have this function plus, then 2, 4, 5 are the arguments. Let's evaluate that. The result there on the right is 11. And this is great. The reason that the prefix notation is great is because you can just add arguments like this. And, oh yeah, just get the result at the end. And imagine if, you know, you were doing it in the tradition that you'd have like 2 plus 4 plus 5 plus, it'd be quite boring. So this kind of regular notation is really useful. Okay, so to define a function, you'd say defn, then function name, and then the names of the arguments you take. So in this case, we're defining something that takes a greeting and the name of the person. So let's define that. Okay. So if we call this function, this calls another function called str, which just glues strings together, concatenates them. So we say hello, hey Matt. It'll just add hey Matt, and then this string here, how's it going? You can also do anonymous functions, which are functions with no name. So we have this function here, it takes x, and if you're not used to Lisp, this might be hard to read, but divides 3 by x, multiplies 2 by x, and then adds the result of those two things together. So we define that function. But because it's anonymous, it doesn't do anything. We're not calling it with any arguments. But in this case, we've got this argument 3, which we're calling with this function here. So if we evaluate that, it evaluates to 7. There's a shorthand notation, which is just having this hash symbol, and then instead of, because you know you've got one argument, you'd have to call it x. You just have this percentage sign instead. So this is the same as the function above, and if you call it with 3, it evaluates to 7 again. So variables, you have namespace scope variables. So let's have gravity as 9.1, then do plus 10 gravity, multiply by 10 gravity. You can also, and this is probably more idiomatic, is you have function scope. So instead of doing def, where you can use the variable for the entire namespace, you do let within a function. So you let pi equal 3.14 in this, and that's only visible within the function there. So yeah, we're calling this function here circumference on 5. It's saying let pi equal 3.14, then multiply 2 by pi by this argument here, which is 5. And we have the result there. Conditionals, the function here, argument, if Lenny equals x, then true, otherwise false. So let's define that. So it's called this function with is Lenny Lenny? Should be true, yep. If is Lenny Bruce? Should be false. It is. Great. With Clojure, you have 2 very basic data structures which are very flexible compared to other languages. You have lists or vectors. They're slightly different in Clojure, but they're essentially the same. So these are vectors. It is like a list. So let's define this list here. And you can call, there's lots of built-in functions for dealing with lists. So the first one is 0. The rest is everything but the first, which is this list here. The nth for is like referencing the fourth, or this one here. 0, 1, 2, 3, 4. Okay. The other really important data structure is hash maps. So let's define this hash map, which is a shopping list. Hash maps are just like key value pairs. So you have the keys here in purple: milk, bread, cheese, wine, and pair numbers here. To add readability, you can actually put commas in between these, but it's optional. So it doesn't make a difference if you do that or not. And just to get the value out of the key, let's get the key for cheese, 3.5, that's right. If you want to get all the values, it returns a list of the values in this mouse function. Okay, so looping is really different in Clojure. There is no kind of for loop like in, well there is kind of, no, there's no real for loop like in Java or whatever. You kind of have to use recursion. And recursion is kind of difficult to understand because to understand recursion you have to first understand recursion. That was supposed to be a joke, but never mind. So we have this function ×2, it takes an argument, items. Recursion, normally, recursion, you have to call a function using its own kind of name, right? But because Clojure runs on the JVM, there's a reason you can't do that. Like normally you have this thing called tail call optimization, which isn't supported by the JVM. So Clojure has this kind of hacky way of doing that, where you don't call the function's name, you instead have this loop thing. So loop is kind of like the outer thing of it. And then recur calls this loop thing. I'm not going to really explain recursion for the reasons that I said before, but trust me when I say that, yeah, this is how you do loops in Clojure. So we call this ×2 on the Fibonacci thing. It doesn't work, because I haven't defined this function. Okay. So there you go. So I've got this ×2 function on this Fibonacci sequence I defined before, and it's just multiplying them all by 2. That's great. So the thing about functional programming is that it provides you really, really great functions for processing lists especially. So we have this map function. Now map function takes a function and applies it to every element in a list and returns the list with that result. So in this case we have map and this function, which is multiply something by 2, and we apply it to this list here. So that results in every element in the list being multiplied by 2. So we can apply that to our Fibonacci sequence, so it multiplies by everything by 2, which is, you know, using this is a lot simpler than using this recursive function here, which is great. Reduce is similar to map, except it accumulates all the values in the list. So it kind of, if you reduce with this function and this list, it applies plus to all of them but accumulates the result. So it just adds them all together. And same with Fibonacci. And we can do stuff like, we have this shopping list here. We want to add all of the values in the shopping list together. We just do val shopping and plus, reduce plus. Filter is also a very useful function. It means take a function and apply it to a list and only return a list where the result of the function is true. So we do filter odd, Fibonacci. That gives us a list of just all the odd numbers in Fibonacci. Filter less than 2, something less than 2, about shopping. This is actually, so this is 2 less than something, sorry. So this returns all the things where they're actually greater than 2. Okay, so lastly I'll talk about macros. So macros are one of the big reasons you want to use a Lisp-based language. They're how you kind of do this meta-programming thing, and how you can kind of define your own programming language or add your new features to the language. So, for example, I mentioned before that Lisp has a prefix notation, where you have the name of the function first and then the arguments. What if you wanted to add a feature where you use postfix notation? So you have the arguments first and then the name at the end. Well, in any other programming language, that would be really hard. You know, you'd have to wait for the creators of the language to add this new feature. But with Lisp, you can add it yourself. So you do def macro postfix and an expression. So it takes an expression that's kind of like a string, I suppose, and this line kind of reverses them, reverses the expression. So if you call this postfix here, how do I go down? So normally it shouldn't understand this because the name of the function is at the end. But because we're passing it into a macro, the macro kind of rearranges it and says, aha, I understand this. So going back to the slides, the reason for this is that macros kind of rearrange the tree of the code. And this is why it's really important that the code is in a tree kind of format. So normally, the function should be at the top, the name of the function. But we've given it a tree like this that it shouldn't understand. But a macro can rearrange the tree into something it can understand. And this is really, really powerful. It allows you to add new features, like I said. Okay, so the IDE text editing thing I've been using is called Light Table. And it's an IDE editor written in Clojure script. Clojure script is the same as Clojure, but instead of running on the JVM, it compiles to JavaScript. So this is another great thing about Clojure. You can use it on the Java virtual machine, or you can use it in the browser, anywhere that JavaScript can run. And the creator of this IDE, called Chris Granger, he created it because he saw a talk by this guy called Brett Victor, which really said that when you create things, you really want to have instant feedback on what you're doing, and that really helps the creative process. So with this text editor, or this IDE, you kind of get feedback right next to things. But there's also this thing called the Insta record, where it gives you, immediate feedback. So you see, yeah, it says exactly what you're doing right next to it. So defining a function here, which adds things. So you can see 3 and 4 are being passed to this function, and it shows you there, and it shows you the result immediately. If you change the function now to multiply, you can see the results updated immediately. Oh, sorry, I don't know what I'm doing here. So please tell me if I'm making mistakes, because, yeah. Okay, yeah, sorry. So this is taking 2 arguments, x and y. And, yeah, if we change those, everything's updated automatically. So this is really cool. And if you're coding something, seeing this instant feedback on what you're doing is really, really helpful. So yeah, that's kind of the principle behind this tool. And in the Clojure community, there are loads of tools like this. Like, there are lots of people who are really passionate about getting this instant feedback and this visualization of what you're doing. Because Clojure really allows this, thanks to the immutability thing. You can really predict what things are going to do. No kind of bad effects of having this, instantaneous evaluation of all your code. So yeah, it's kind of built for this live coding. This editor also supports JavaScript, Python. It's really designed for Clojure and Clojure script though. So I talked about live coding. I'll give you a better example. I showed you this now in the editor, but here's how live coding can help you program a game. So we have Clojure scripts on the left here, and a game on the right here. So we can actually play this game now. It kind of runs on the right here. But if we edit the code, so let's change the value of gravity to, I don't know, 1.5. And immediately you can see gravity is a bit stronger. Let's change it to 0.1. And, well, that's not working. 1.1. Okay. Yeah, it doesn't seem to be working. Speed. Change the speed to 50. What does that do? Okay, well, this has stopped working. It's a real shame. Okay, but yeah, the point is that like if you can change. I'll try refreshing it. Oh, I don't have the internet. Can I? This is the problem with doing a live demo during a talk. Sorry?
There's no Wi-Fi.
Okay, there's no Wi-Fi. Okay. Well, hopefully there's cache so I can go back. No, okay. Well, sadly I can't show that to you, but hopefully what I could have shown you was that when you're editing something and seeing the result as you edit it, you can, kind of like in this editor, like, it really helps you to be able to see what the effects are. And I was going to show you an example of programming a game where you could see the result of the change of gravity, the change of speed. There's also this thing where you can pause it and you could see kind of the history of what it was. It's hard to explain though. I will put a video up of like this thing, or put a link up onto the meetup group, so you can actually see it. Okay, whatever. But I wanted to talk about how you can use Clojure for coding things creatively. And there are loads of projects out there, like for creative coding. And one of them is called Overtone, which is actually how you use Clojure to build synthesizers and compose music with like code and algorithms. And a lot of people use it for like live coding performances. One of the famous examples of this is something called Clojure, which is a programming language for synthesizers and composing algorithmically. And this Overtone thing, it's Clojure, but it hooks up to the synth engine for Clojure. Okay. So I'll try to give you an example of that. Hopefully this one will work. Okay. So this is Overtone. I want to define an instrument. Let's call it, I don't know, I'm telling it takes a frequency, but the default value is 220. And let's make it a sine wave of the frequency that you give it. So if I call foo now, this is a sine wave with a frequency of 220 Hertz. So let's change it to 440. There you go. Pretty cool. Let's have another instrument. Let's have this one as a square wave. So you can use this to make synthesizers. So you could use additive synthesis to multiply two sine waves together. So let's redefine that. And you can change that on the fly by using this. This whole live coding thing means you can play around with what we're doing and see the result instantly, which is pretty cool. Another project is called Quill. How many of you have heard of something called processing? Okay, so some of you. Processing is this coding environment which is similar to Java, but it's greatly simplified. And it's geared towards artists who want to code things and generate artwork with code. So, like, Quill is kind of like that, but brought into Clojure. So it actually uses all the processing libraries. And yeah, it has the same uses as what you'd use processing for, which is for interactive art installations and that kind of thing. And I'll try this, I'll try to give you a demo of this. I have to exit full screen. Okay. Right. Now hopefully this will work. So we have this code here. The thing it's the same as processing, if you know it. So processing has a setup function, which just sets up everything originally. What am I talking about? And then a loop, which draws everything. A loop is called like continuously, and it's used to draw everything on the screen. And this uses the same kind of thing. So the setup, I say, okay, let's smooth everything out with anti-aliasing. Frame rate is 1, background color is this shade of grey. And draw, and this gets called continuously, and it draws, it says, okay, let's have the stroke this color, the line, the stroke thickness this and fill it with this color. And this is just drawing circles. So hopefully if we evaluate this, it should do something, but it's not. There we go, okay. So it's generating circles. So every time this draw thing is called, which is, we've got our frame weight is 1, which is, it calls this once per second. So we're drawing these circles. But let's change this field to, so random 255, let's give it extra arguments. If it has one argument, it knows that's a shade of grey. If it has more arguments, that's RGB values. So we've changed that now, and it's drawing green circles. That's great. Change the stroke color to, I don't know, I have no idea what this color is going to be. And then the outline is changed to kind of reddy brown. Let's change the diameter to 10. And now you've got tiny little circles. Let's change it to 500. Massive circles. That's great. So it's great. You can see it's really useful to have instant feedback like this. And a lot of people in the Clojure community, like I said, are creating tools that allow this kind of thing to be easily done. Let's close that. Okay, so back to the talk. So yeah, why would you use Clojure or Clojure scripts? Well, I think if you're programming and you use Java or Python, Ruby, JavaScript, that's very good, but it's useful to learn other things and expand your knowledge. And I think once you learn a dialect of Lisp, you kind of have this this kind of epiphany that, wow, programming is not just the stuff I've learned, there's this other really cool stuff out there. So it's really good for kind of expanding your knowledge. And I think functional programming, like the kind that Clojure really emphasizes, is really the future of programming. I mean, you see like these modern languages, like I've told you before, like Ruby and JavaScript, Python, they kind of have all these functional like design elements and kind of combining it with object-oriented, but it seems like languages are becoming more and more functional, adopting more of a functional style, which is great. So I think, yeah, things are going more towards this style of programming. The Clojure community is amazing. Like, they're really, really friendly people. If you go onto like IRC or any Clojure mailing list or whatever, you get really good help. The tools are great, like I showed you the Lighttable IDE. People are designing really good tools for using this programming language. And the creator of Clojure, Rich Hickey, he's the guy with this kind of vision, and he is exactly the kind of person you want behind a programming language. He knows what he's talking about. He makes amazing decisions with regards to design of the language. He's a really good reason to use Clojure. If you see some of the videos with some of the talks he's made, there's one called Simple Made Easy. I really recommend watching that. It's really enlightening. Okay, so if you want to learn Clojure or Clojure scripts, I recommend a free online book called Clojure for the Brave and True. It's here at braveclojure.com. Also, if you want to learn Clojure or Clojure script, there's this GitHub repository, which is kind of similar to what I was doing in Lighttable in that editor there. It has like a list of things and you evaluate them step by step and play with them, and that's a really good way of learning them. I mentioned before that I'm one of the organisers of the Bristol Clojure Dojo, or the Bristol Clojurians. So if you're interested in learning Clojure, then I really recommend you turn up and we can work on some Clojure together and learn together. So our next meetup is May the 20th, and it's at Nokia headquarters, and we're learning Overtone. So that's the synthesizer music that I just showed you just now. And it should be a lot of fun. So yeah, if you want to contact us, we've got a website with just Bristol Clojure on Twitter. We've got a meetup group. So yeah. So if you've got any questions, just send me some tweets. I know Peter just arrived just in time. And yeah, the slides are online at this address. So that's it. If you've got any questions, feel free to ask them. But Peter has arrived, so it'll be good.
Peter has arrived.
Yes. Okay.
Then let's stop and ask some questions.
What time's the meeting?
It's 6:30. hope to see you. So yeah, thanks very much. Cheers.